Hello. Now we are going to look at an introduction to probability, or at least theoretical probability. That is, to begin with, we're going to look at where all of the outcomes that we're looking at are equally likely. So the probability of something happening, which we will write as capital P brackets E for the event, for the thing that's happening, is equal to the number of ways that event can happen. So the number of wanted outcomes, the number of things we want to see happen, divided by, so this is a dividing line, so it's a fraction, so a dividing line, the total number of outcomes. Or writing it in set language, it would be the cardinal number of E, the number of ways that the event E can happen, divided by the total number of ways that things can happen in the universe, so the total number of possible outcomes. And this type of set type language, this more formal maths language, is very useful for translating big English blocks of text into something that we can work with very directly mathematically. So we'll work on using this kind of language for our probability questions a lot. If we take an example, there are 20 marbles in a bag. 7 of them are red, 8 of them are blue, and the rest are yellow. So we're going to come back to, if we want to find the probability of picking a blue, we're going to come back to this definition here, and this is going to get us very far in probability. We're going to look at how many of these outcomes do we want out of the total number of outcomes. So if we want the probability of getting a blue, I would call that P of capital B. So I keep track of what I'm looking for, the probability of getting a blue marble is going to be the number of blue marbles. These are all of the marbles that I want to pick if I want to get a blue, out of the total number of marbles that are in the bag. That's effectively my universe, because those are all of the things that I'm interested in this question. So the number of blues divided by the number of marbles overall. So wanted over total. And if we want to get really good at telling ourselves the story of what we've been asked for. So in this case, we know exactly how many blue marbles we've got, and we know how many marbles we've got in total. So now all that falls to us for getting full marks in this question is to simplify the fraction. So I see I have a common factor of 4 top and bottom. So I can write that as 4 by 2 over 4 by 5, which is 4 all over 4 multiplied by 2 all over 5. 4 over 4 divides it into itself 1, so this is just the number 1. So I have 1 by 2/5 is just 2/5. You could also just divide above and below by 4. But either way, we must always give our probability answers, as with all of our answers, in simplified form. We must fully simplify our answers in order to get full marks. So we can see how using our wanted over our total gives us our probability. Let's do one now for yellow. So probability of picking a yellow. So we write down what we're asked for, and we describe it to ourselves in mathematical language, the number of yellow marbles divided by the total number of marbles in our universe, in our bag. But we have a problem this time. I don't actually know how many yellow marbles I've got yet. I do, however, know that if I add up the number of red marbles, blue marbles, and yellow marbles, I must get 20 marbles overall. So now what falls to me is to say, well, my yellow marbles plus my number of red marbles plus my number of blue marbles must add up to the total number of marbles in my universe, in the bag. So my number of marbles, my number of yellow marbles must be number of added to my number of red marbles is 7 plus my number of blue marbles is 8, must add up to 20 in total. So I add my like terms, and I get my number of yellow marbles plus 15 is equal to 20. Rearranging my equation, I get that I must have 5 yellow marbles in the bag. 5 yellow marbles. Where are we gone? 5. Another way to look at this problem would be the number of yellow marbles would be the total. Just rearranging this equation, and in our heads it would be number of yellow marbles would be the total minus the number of not yellow. So that's another way of looking at the same problem. The number of yellow marbles must be the total number of marbles I've got in the bag minus all of the ones that aren't yellow. Now, let's come back to our question now that we know we have our 5 yellow marbles. So we have 5 yellow marbles out of our total is 20. So I have a common factor of 5 top and bottom. And when I simplify that, 5 divided by 5 is 1. And again, I can just divide above and below by 5 as well, but if we can think in terms of common factors, it helps us in other areas. So that's my answer. Now, what's the probability of not picking a red? So, of not picking a red. So the probability of not picking a red. Well, that would be the number of not red all over the total number in my universe. So my number of not red would be my number of yellow plus my number of blue, and I now know my number of yellow, so I could do that. There are several ways you could construct this one, so that would be the same as saying the number of blue plus the number of yellow, divided by the number in my universe. So that would be my number of blue is 8 plus my number of yellow is 5 all over my total number in the universe is 20. So I would end up with 13 out of 20. There's another way to look at this question, which is very useful for some questions that we will come across, which would be that the probability of not red would be the total probability, which would be 1. The probability of picking any of our marbles would just be 1, because we're guaranteed to pick one marble if we pick a marble out of the bag. So that would be 20 out of 20, or 1, minus the probability of picking a red. So that would be equal to 1 minus probability of picking a red is just 7 out of 20. And when we do that at fraction subtraction, we would end up with 13 out of 20 as well. So this idea that the probability of not getting something would be the total, the probability always totals to 1, minus the probability of getting the thing, is a concept that will be very important in some questions going forward. Now, the other thing that we want to think about in terms of our probability questions is stuff like dice. So a 6-sided die is a very common thing that it comes up in a question. And another very common thing that can come up in a question is a card deck. So somewhat unexpectedly, you're required to know quite a lot about a playing card deck as part of the exams in maths. They won't tell you this information in the exam. You have to know it by heart. So in a card deck, there are 2 colors, red and black. So you can see the 2 middle rows here, our hearts and our diamonds, we'll come to that in a moment, are red, and then the top and bottom row of our cards are black. So those are our 2 colors. Then we have 4 suites, we call them: diamonds, hearts, clubs, and spades. The spades and the clubs are black, and the hearts and the diamonds are red. And you are expected to know that. Inside each one of the suites that are all the same, we have an ace, and then the number cards from 2 up to 10. Then we have jack, queen, and king. And those are all of the different cards that are in each one of the decks. You can see that, or suites, I should say. All of the suites are exactly the same, except that they have either hearts or diamonds or spades or clubs symbols in them. But they all have ace, the ace card, then the 2 up to 10 in the numbers, and then jack, queen, and king. And again, this is information that you are required to know by heart. So let's put this into practice in a question. Sorry, one final point. That gives you a total of 52 cards in the deck. So 4 times 13 cards is going to give you 52. We do not include jokers in a standard card deck unless they specifically tell you to do so in the question. So for the vast majority of probability questions, jokers are not included. You would only include them if they specifically tell you to do so in the question. Otherwise, we ignore them. Now, what's the probability of getting a king? Well, let's write down our question in our probability language. That would be the probability of getting a king would be the number of ways that we can get a king divided by the total number of cards. So wanted over total. Well, how many king cards are there? Well, I have this up on the screen. So we have the king of spades, the king of hearts, the king of diamonds, and the king of clubs. So there are 4 kings in the deck out of a total of 52 cards. So that means we have a common factor of 4. And I will, you can use your factorizing method, or you can divide above and below by 4. In this case, I'll do divide above and below by 4 because it's a common factor of 4. And you would end up with 1 out of 13. Next question, the probability of a red card. So that's the probability of getting a red card would be the number of red cards all over the number of cards in total. Wanted over total. We keep coming back to that time and time again. So we have red cards. So we count up our red cards. We see we have 2 red suits. We know there are 13 cards in each one of them in the hearts and the diamonds. So if we add them up, we have 26 cards out of 52. Now, visually, you can probably see from the deck that half of the cards are red. And indeed, there is a common factor of 26. So this will simplify to a half. But we would always, 26, we would always write our answer in this form first and then simplify. Even if we know the answer is a half, we would write down 26 out of 52 first, and then we would simplify to a half. We would never just write down a half because it doesn't show where our thinking is coming from. Now, what's the probability of getting a red jack? There are 2 different ways of doing this, and we will look at both. So a red jack. Well, how many cards meet that description? We have red. How many red jacks do we have out of our total number of cards in the universe? So we have a jack of hearts and we have a jack of diamonds. So those are our 2 red jacks. So we have 2 red jacks out of a total of 52 cards. Divide above and below by 2. And you end up with 1 out of 26. So you have a probability of 1 out of 26. The other way of looking at this problem, that is the way that we would do that. We will look at other methods later on. The probability of not a diamond. So the probability of not getting a diamond would be the number of ways of not getting a diamond all over the total number of cards. However, you can also think about it as the probability of, the total minus the probability of getting a diamond. So you can look at this question in both ways. So we have the number of ways of not getting a diamond. Well, how many cards are not diamonds? So our diamonds are our second red row down here, and you could count up all of these cards, and you get 39 out of 52, which simplifies down to 3/4, or you could say 1 minus 13 out of 52. That's the probability of getting your diamonds, and that will also simplify to 3/4 when you do add the sum. So both ways are important ways of understanding the question. And that is what we need for now.